In this video, we're looking at problem 824, which is the future value of an annuity due. So I want to just right off the bat say you're only going to need one of these rows right here because the problem only gives you one set of numbers. I put in 4 here just so you could play around, but just put in the right answer here in the top, or just somewhere in here so I can see it. But this top one up here obviously is for you to play around with and see what's going on. So the takeaway here is the difference between the future value of an annuity and the future value of an annuity due. And you can see if we start off with a payment of $25,000 a year at a 3% annual interest rate, and we receive this payment for 10 years, then the future value of the annuity is $286,000 plus. The future value of the annuity due is that plus one more payment. So and the formula, there really wasn't, I couldn't find the actual formula in the book, but what you're actually doing here is you are looking at the payment happening at the beginning of the month instead of at the end of the month. So over this period of time, or at the beginning of the year in this case, so over a period of time, you're going to get one more payment. So if we read, this is what I pulled from the book right here. You're going to multiply the answer. So the future value of the annuity due is the future value of the annuity multiplied by 1 plus the rate of return. So if you look right here, the formula is whatever we have which is G13. So whatever we have for the future value of the annuity right here, multiplied by 1 plus the rate of return, which is in E13 right here. So that's where we get that. So when we read about that, we just simply we multiply the future value of the annuity, or the present value of the annuity formula, by 1 plus K, the rate of return, because annuities do have annuity payments earning interest one period sooner. So the higher FVA and PVA values result with an annuity due. The first payment occurs sooner in the case of a future value of an annuity due, and in the case of the present value of annuity due problems, each annuity payment occurs, so the payment occurs one period sooner, so the payments are discounted less severely. So we'll see how that works in our next problem. But for this one, you just simply need to put in the right numbers in the top row, or any one of these rows down here, and you'll be fine. And you can once again see that if we change any of these numbers, if we have a higher payment, we'll have a higher future value both of the annuity and of the annuity due. If we have a higher rate of return, or we actually have payments that go for longer, more payments over a longer period of time, obviously that's going to increase the future value. So if we just want to just go right here and just change this to 20, you can see that 1,400,000 or something, or whatever it is, turns into much more, right? 3 million and a half, right? So you can play around with this. It's I think it's kind of cool to see how changing different variables here change your future values. Okay. And once again, make sure you put just your one answer, because there's only going to be one row here that you're going to need with your numbers from the problem. And I see. What you're going to want to do, though, is you're going to want to experiment. So it says okay. So it says the account manager has found that the future value of 10,000 deposit at the end of each year. Okay, so your payment's going to be $10,000, and it's going to be for 5 years, and an annual rate. Oh, I see, right? And then okay, so it's going to be fine. So once you put this in, this will calculate the this formula that I have right here will calculate the future value of the annuity due from the future value of the annuity, which is this amount of $52,040.40 right here. Okay,